Are you able to see the screen?
Yes, sir, we can see.
Okay. I'll put on view graph. Thank you, Dr. Mahapatra, Dr. Singh, the organizers. It's really a great honor to be invited to speak today, especially on the 75th anniversary of our independence. I feel greatly honored and privileged to be invited. Thank you so much. The topic of the discussion today is making agriculture a solution. And I think I'd like to begin with connecting children with nature. If we were to really attract the brightest and best to agriculture, somewhere along the line, the children right from the primary school have to be involved in this great resource, and they should feel where the food comes from. It does not necessarily come from grocery store. So they have to be connected with nature. And that's a very important part. In addition to 3 R's, the goal of the education right from the kindergarten is to prepare the next generation to address global issues. Global issues of food and nutrition, environment, which is soil, water, air, biodiversity, and the personal responsibility. Each one of us is a culprit and victim of these environmental changes that are happening today. And that is an ethics, integrity, and respect for nature that children must learn from the very beginning. They must realize what the soil is, what a healthy soil feels like, what playing with a healthy soil has a pleasure of connecting with nature. I have not seen many children book relating to nature. I've not seen many books of children trying to understand what nature is. So IICA, Institutional Cooperation in Agriculture for the Americas, have just recently come up with a book exactly on that topic. I want to show you a slide of the cover page of the book today, but I was unable to do that. But I think there's a need for the alphabet book. A is for agriculture, S is for soil, E is for earthworm, L is for life on land, C is for climate, so that they understand these things right from the beginning, where the best ecosystem services come from. For 300,000 soil series, there is really no one agriculture that fits all. If we think that's the case, that would be very naive. But most importantly, the children should know that forest and biodiversity, the water resources, the animal biodiversity, the energy biofuels, the aquaculture, the climate regulation, food production, ecosystem restoration, and indeed the future of humanity. We had a discussion on Ladki. It is one. Depends on making sure that the next generation understand agriculture and what it is. In fact, we would like to show them the basic concept in soil we trust. Those of you who are familiar with the coins in the US, you will understand what I mean by that. The global issues that we are talking about, that we are facing at the moment throughout the world, means issues such as soil degradation. 1/3 of all soils are degraded. Agricultural emissions are increasing at the rate of 1% per year. Prevalence of undernutrition of the COVID pandemic has gone from 690 million to 820 million. Malnutrition is affecting 2 billion people globally. Fossil fuel combustion, even last year, is 10 billion tons, 9 zeros of carbon per year. Water pollution and scarcity are aggravating. Urbanization, especially in Asia and Africa, is escalating, and the food waste is globally increasing. In fact, the most recent estimate of global food waste is 1.4 billion tons. That means the land required to produce 1.4 billion tons of wasted food is equal to that of South Asia. The Green Revolution, a great success story of agriculture ever from 1961 to 2020, which produced the population increase from 3.1 billion to 7.8 billion, 2.5 times, but the cereal grain production increased 3.3 times. In fact, this year, cereal grain production is more than 3 billion tons. Consequently, contrary to the Malthus concept, the cereal production increased 32% from 284 kilograms globally to almost 380 kilograms. And this is what people are beginning to call the Borlaug effect. Dr. Mahapatra and colleague, Dr. Paroda, Dr. Swaminathan, they will all agree what the Borlaug effect, which saved hundreds of millions from starvation. But let's take a stock of it. How did it happen? Obviously, varieties played a very, very pivotal role. Dwarf variety, which were large with the input of fertilizer and irrigation. The nitrogen fertilizer increased by a factor of, I have some problem with my computer, do not exactly know what it is. I hope it's not jammed. Yes, it is. That is the unfortunate part.
No problem. You can just close the presentation and restart. Just the presentation, you should be okay.
Okay, I may have to restart the whole computer.
Sir, you can continue. Sir, you can continue and share the PPT. Later, I can share to the group. That should be also okay.
Okay, let me cancel this and see.
If you have other place to.
Okay. Can you still see the slides?
It stays. Yeah.
Yeah.
Okay.
We can see slide number 10.
Yeah, but it's okay. All right.
Yes.
So fertilizer went up 10 times, phosphorus 5 times, potassium 5 times, pesticides at the moment 4.2 times, irrigation went up 2.5 times. So already mentioned this morning, US agriculture, one farmer feeding 166%. Indian agriculture has followed the same trends, which is a really a great attribution that we should give to our farmers, policymakers, and scientists in India. Food grain production, tremendous increase, and it can be as much as perhaps 500 million tons by 2050. Fruits and vegetable, milk, fish, edible oil, everything in India has gone up tremendously. At the same time, if you take the carbon stock in the atmosphere, then before agriculture, it was 360 gigaton carbon stock, 360 gigaton. Before the Industrial Revolution, it was 560 gigaton. So 200 billion tons of carbon in the atmosphere between 10,000 years ago when the agriculture began to 1750, 200 gigaton increase came primarily from land use and agriculture. There were no fossil fuel yet. At present is 880 gigaton. So this 320 since 1750 gigaton increase has come both from land use conversion, agriculture, and fossil fuel. Total fossil fuel emissions in 1750 is 445 gigaton carbon, and total emission from land use change in agriculture is 575 gigaton of carbon. Therefore, if we can put carbon back in agro ecosystems and land, somehow that has come out of, taken away, and at the same time find alternative to fossil fuel, keeping the global warming to less than 2 degrees centigrade is still possible. Per capita annual emission, US 15.52 megagram carbon dioxide. equivalent per year. China 7.4, India almost 2, world average 5. If we were to bring down the per capita emission globally to about 2 gigaton of CO2, yes, climate change mitigation can happen. Global soil degradation is really an important issue, comprising 47% of forest land, 18% of cropland, 2 billion hectares of degraded land, including that in India, from a range of processes: erosion by water and wind, salinity, acidity, complex problem, almost 120 to 150 million hectares of land degraded in India. We talk about endangered species, we talk about peak natural resources. I think that concept must be extended also to soils. Indeed, we are reaching the so-called peak soil. The per capita prime soil required to meet the basic necessity of one person with a good standard of life is about 0.25 hectare. There are many countries, especially in South Asia, where the per capita arable land is almost 0.05 hectare. India is more, India is 0.11, 0.12. That has created the problem of land grab and the soil refugees and the climate refugees, a global issue almost affecting 90 million people. So yes, there is a peak soil, there is endangered soil. We have extinct soil, soil which have lost their original identity because they have lost their top horizon. I mentioned food waste global, per capita food waste, in spite of all these issues, North America and Oceania, the CO2 emission from the food waste taken to landfill, 860 kilograms of CO2 per person per year in the US and North America, industrialized Asia 810, Europe 680, Latin America 540, North Africa, West Africa 350, South Asia, including India 350, Sub-Saharan Africa 210. This is not acceptable. This has to be avoided. Then there's the question of urbanization. The rural population is decreasing globally, the urban population is going up. The transition point happened somewhere about 2008. US urbanization happened a lot earlier. In 1918 was the point when the urban population, the US went up. Urbanization is really going very, very high everywhere in the world. In the US, only 3% of the entire urban area, home to about 80% of the US population, and conversely, 97% of the country's landmass is rural, but only 19.3% of the population lives there. Urbanization in India, New Delhi population from 1.2 million in 1950, expected to be 36 million, 30-factor growth by 2030. Calcutta 4, Bombay 9, Pune 10, Hyderabad 12, Bangalore 21, Chennai 10. The reason I'm bringing this up, because if the majority of the people are living in the cities, probably our agriculture as we know it now has to change. We have to think about urban agriculture. We have to think about the nutrients and water which are being used and brought into the cities, these mega cities. Somehow we have to produce food within the city by recycling those nutrients. That brings me to the question what was discussed on the 23rd of September 2021 by the Secretary General of the United Nations, talking about the food systems conclusion. And the question came up, what are the limitations of the present food system, including those of India? They have failed to end hunger and malnutrition. They haven't provided adequate, nutritious, and healthy diet and safe food to all. They have degraded soils, polluted water, aggravated global warming, dwindled biodiversity, and denuded landscape. I'm not talking about agriculture. I'm talking about the food system. Food system is right from the production agriculture all the way up to consumption, including the packaging, transport, cooking, and use. And in spite of all that, 30% of all greenhouse gases come from food systems. Only 14% come directly from agriculture, but the food system contributes another 16%. COVID-19 has disrupted food system tremendously, both food production and supply chain. It has adversely affected commodity markets and trading system. It has reduced economic growth and income. It has aggravated poverty. It has increased risks to human well-being. It has worsened inequalities, including gender, racial, and cultural and ethnic. It has aggravated under and malnutrition, especially in children and women. Therefore, our food system have to be pandemic proof. That is one lesson that we have learned. We have to there is a strong need to make food systems resilient to pandemics, in addition to extreme climate and other stresses. Therefore, how will we bring about the transformation of food system? Number one part is restoring soil and biophysical environments. Biophysical environments, the air, water, biodiversity, the landscape. Improving social equity, and the gender equity was discussed already prominently this morning. Addressing human dimensions, adopting prudent governance, and I repeat that prudent governance part, identifying and implementing site-specific game-changing solution that will improve the food system. And of course, strengthening human resource development. That's why I began this discussion this morning with children, connecting them to nature. That's the future. And therefore, creating global science policy interface for sustainable food system. The transformative strategies, what are predominant now globally, including in India, are 5 Ds. What are those 5 Ds? They deplete, degrade, destroy, discard, and dominate nature. They take land away from nature. They must be transformed, changed to 5R instead. And what are 5R? Reduce, reuse, recycle, regenerate, and restore. And these 5R will return land back to nature. Some land, toward the end I'll come back, how much of that land can be returned back to nature. Therefore, the one thing which was brought up in the introduction, the soil, human, planet health nexus, the health of soil, plants, animal, human, environment, and the planet is one and indivisible. If the health of soil goes down, health of everything else dependent on it also goes down. Therefore, food and nutritional security research everywhere, especially in India, must also address environmental and resource management issues. They must go hand in hand. We cannot address food and nutrition security and neglect natural resources. That's an important part, because soil is life. And soil is a living entity. That is very correct. It is only the living soil that can support life on the planet. If soil is not living and not healthy, everything else dependent on it is not healthy either. And what is the soil health? It is soil's capacity as a dynamic and biologically active entity within natural man-made landscape to sustain multiple ecosystem services, both for human and nature. Many times people talk about profitability. Profitable to who? Human? Not good enough. It has to be profitable first to nature, and human are part of it, and they benefit from it if nature benefits. Therefore, managing soil health involves regenerative agriculture. Regenerative agriculture, as much as I like organic, is not just organic. Please do not confuse. Regenerative agriculture is any agricultural practices which restore landscape, any. And there are many options. There are indeed many options. Precision agriculture, artificial intelligence, biofortification, soil, water, and air energy nexus, building new soils, and above all, soil-less agriculture, soil-less farming, farming which does not even involve soil. And that is what we are thinking about, how we can restore the natural resources again and create at the same time drawdown of CO2. So these are the basic principles. What can come from those principles under site-specific condition is not one practice. These are one concept. And on that concept, many things can be developed. So please don't be narrowly focused. Look, a humongous problem that the world is facing requires very innovative approaches. So what is this regenerative agriculture? It's not one practice. It's an ideology. It's a philosophy. It's a concept. It's inspired by eco-innovation. It's powered by non-carbon energy. It's driven by a circular economy, and green infrastructure is supported by the recarbonization of the terrestrial biosphere. Remember that 550 gigaton of carbon that have been stolen from the nature, put it back at the bedrock of sustainable development. Is there a one practice to do that? No. And the idea is continuous soil cover. The idea is no soil disturbance. The idea is integrated nutrient and pest management. The idea is complex rotation and cropping system with cover crop, of producing more from less by restoring soil carbon, by restoring soil health, by eco-intensification, by regenerative agriculture. What the regenerative agriculture is depends on the site-specific situation. The whole goal is to treating soil like a bank account. And in a bank account, if you wanted to increase, the deposition in the bank must always be more than what you withdraw from the bank. And deposition of carbon in soil can be by many things, many practices. There are some examples, and they must always exceed the losses from soil of carbon and other essential material by erosion, leaching, decomposition, harvest, whatever else can happen. Unfortunately, in most cases, especially under resource-poor farmers, the left situation where the gains and deposition into the bank account is less than the losses is the dominant part. We must be thinking about the carbon-based fertilization concept. We always talk about NPKs. So basically, yesterday I was talking to a colleague of mine from Brazil. We were discussing how much of carbon can be put back in the soil of Brazil. And I would really like Dr. Mahapatra and colleague to visit some of the long-term no-till farming in Brazilian, 36 million hectares of it is present, much better than in the US. Here's an example, a cover crop suppressed and another crop planted through it. And if that cover crop happened to be a legume, then the carbon in soil goes before NPK. If the carbon of depleted soil in many agriculture soil now less than 0.5%, where it should be 2%, if it can be brought up to 2%, maybe in 2 decades or 3 decades, it's not going to happen overnight. The need for NPK will progressively decrease. And that's the part which we need to consider. So the idea is soil farming by eco-intensive. Remember, I'm talking about soil farming. I'm not talking about crop farming. The strategy is to produce more from less land, less water, less fertilizer, less pesticide, less energy, less emission of greenhouse gases, so that some land can be returned back to nature. Some of the estimates of how much crop yield can be improved with all other factors remaining the same by adding carbon in soils to 1 metric ton per hectare, 1 megagram, that's 1,000,000 grams, 1,000 kilogram. Maize, about 100 to 300 kilograms, soybean 20 to 50, Many research data from Dr. Srinivasa Rao and others have estimated these values for India also. Different crops, total globally about 40 to 100 kilogram per hectare of grain for every 1 ton increase of soil organic carbon. So if you can add carbon in soils of India by 10 tons, you can see the magnitude of increase that can happen with the same level of input. So eventually we save land and water. Globally, people ask how much carbon can you put back in the soil? Well, the estimates vary, but one that we range from 1.5 to about 3.5 petagram, that's gigaton, which is about 2.5 gigaton of carbon per year. So between 20 and 2100, about 15 of us put an article together a few years back. Soils of the world can absorb about 180 gigaton. Vegetation, forest, woodland can absorb 155. Total between 2020 and 2100. Land can be a sink of atmospheric CO2 about 333 gigaton, which translates into drawdown of atmospheric CO2 by 157 parts per million. Therefore, if we can find non-carbon fuel sources, and India's solar energy is a very good example in Rajasthan and other areas, then land-based sink can definitely create a drawdown so that global warming can still be less than 2 degrees centigrade. It is still possible. It's yet not too late. So land-based solution certainly have very important role to play. To do that, we have to go back to farmer to make sure we reward them. And this reward to farmer, which I'm going to suggest now in a moment, is not a charity. It's not a handout. It's not giving a baksheesh. We are demanding from them to do something good for the land. And the real price, the societal price, is about $130 per ton. This was the calculation I made in 2013. That comes to about $35 per credit of carbon, $35 per ton. So if farmer sequesters half a ton, that's $26 per acre or $65 per hectare. If a farmer sequesters 1/3 of a ton, $43 per hectare or $18 per acre. Some companies are paying about $6, $8, $10 credit at the moment. I don't think it's enough. Undervaluing a very precious resource such as carbon, soil health, leads to tragedy of the commons. And we are already suffering from that tragedy. I mentioned urban agriculture and the soil-less agriculture. I think by 2100, the agriculture as we know it now, especially urban population, being by that time about 90% of the total population, we should be really thinking about aquaculture, aquaponics, hydroponics, aeroponics, aerofarm, artificial soil, synthetic soil, so that the natural soil with many ecosystem services, many of them we do not know even yet. For example, 95% of all antibiotics that are taken by human and animal come from microbes in good soils. So we can save them. And this is soil-less agriculture, especially is important in many water scarce areas, such as Middle East, such as Northwestern India and Southwest United States. In this regard, the private sector's role cannot be overstated. Private sector has to play a major role. They must be the one who are important in translating science into action. Private sector can play a major role by promoting nature-positive agriculture, whatever that might mean. And that might be very different from place to place, from soil to soil, from ecoregion to ecoregion. They can provide increased access to improved varieties, improved seeds, machinery required, and they can lead to investment in agriculture research and development. It's not only just the government that should be pushing the agriculture research. Private sector can also do it. And that's a very important thing that they should take care of. Cooperation with private sector in terms of sustainable development goal is very critical. Goal number 1, and poverty. Goal number 2, zero hunger. Goal number 6, water sanitation. Goal number 13, climate change action. Climate. Goal number 15, life on land. All of them, private sector, have a very, very important role. I'll list it here. PepsiCo, one company that's certainly working with us, and with LISM, Living Soils of the Americas program. All other companies, Syngenta, Microsoft, Corteva, many other seed producing companies, and of course, policymakers, academicians, international organization, ICAR, IICA, land manager, they all have to be interlinked together to address this humongous problem that the world is facing at the moment. Technological innovations between 2020 and 2050, I see many space farming on soil processes, hypergravity conditions, or robotic soil-less agriculture, precision agriculture, the interconnectivity. A very good example that I can think of interconnective is John Muir, an American philosopher last century, who said, in nature, when you try to pick anything, you find it's hitched to everything else. Nutrition sensitive farming, I cannot overemphasize. All the microelements, 17 of them, protein, vitamins, everything must come from the food, and they must come from soil. Yes, varieties are very important, but varieties cannot do the miracle if they are grown in a degraded soil. So agriculture focus has to be on nutrition sensitive, not only just the yield, nutritional quality of the produce. That means the price of the product in terms of quintal, dollar or rupees per quintal, should it be based on the nutritional quality or just on the amount? And I think we have to think about it. And if the quality of the food produced on degraded soil is not good in terms of the nutritional value, then its monetary value cannot be as in that grown from a good soil. And that's a very important policy issue, nutrition sensitive farming. We have 2 billion people who are suffering from malnutrition. And that healthy food, healthy diet must come from healthy soil. Farming soil with the plants that emit molecular-based signal. I'm not a plant geneticist. Dr. Mahapatra and other people know whether this is possible. I'm told there are some plants called sentinel plants. They emit molecular-based signal, different signal under different stresses. For example, drought stress, nutrition stress, global high temperature, biotic and abiotic stresses, different signals. If that is possible, then we can have intervention before serious damage is done. So this kind of looking at possibility of the plants which generate signal, something very important. And of course, farming carbon. What's farming carbon? Carbon then becomes a commodity that can be bought and sold and traded in the market and create another income stream for farmers. And that's what farming carbon. Carbon is another crop. In fact, carbon, I see the US has now an act called Growing Climate Solution Act. It was passed by the US Senate last year in 2021. And I think the next farm bill probably will have a payment to farmer for carbon. I was listening to Secretary Wilczek the other day when he mentioned 89.6% of the farmers in the US have to have an off-farm income to make both ends meet. That's probably equally the case everywhere else. Therefore, if carbon becomes another commodity and farmers are paid transparently and judiciously and prudently and justly and fairly, the real price of carbon, not just a token price, then carbon becomes a farm commodity. So I'm asking, making suggestion, a board, rather a soil scientist suggesting to plant geneticist and breeder, the world's famous today attending this session, that what kind of varieties we need and what kind of new crops we need. Please help. The one health concept, the health of soil, plants, animal, people, ecosystem, and the planet is one and indivisible. This concept did not come out very clearly in the UN Food System Summit. The Secretary General, obviously, of the COVID region simply linked human health is linked to animal health. Yes, sir, it is. But it's a much bigger concept than that. And this concept, by the way, came from India, from Indore, 100 years ago, by the then president of the Indian Science Academy, Sir Albert Howard. Sir Albert Howard's lecture to the Indian Science Academy was titled Health of Soil, Plants, Animal, and People is One and Indivisible. 1943 Agriculture Testament book had that lecture in it. Please have a look. Going back to children connecting with nature, very important. Why is it true? Why is it happening that an agricultural graduate gets 10 times less salary than a graduate in medical? Why is it that a farmer gets less respect than those which are engineers and in other professions? That change, that transformation, that revolution has to come right from the beginning. The children are in the kindergarten. They should be connected with nature. They have to understand what nature is. Therefore, they respect it when they grow up. I think 5 billion hectares of land under agriculture globally now, 1.5 billion hectares under cropland, and 3.5 billion hectares under grazing and pasture land is far too much than we need. Of the 5 billion hectares, if we change our diet healthy diet for the healthy planet, and if we have a value of nature, then half of that land by 2100, within the next 80 years, must go back to nature. It has to go back to nature. And we think about soil-less agriculture as a part of that. And the mantra to do that, which I promoted at the World Food System many times, I don't think I succeeded very well. And the mantra is that the healthy soil equal to healthy diet, equal to healthy people, equal to healthy ecosystem, equal to healthy planetary processes. This is the message I would like to leave with you for the 75th anniversary of India's independence. Thank you very much.